This presentation is about project complexity management. And I'm an IT engineer. I've been working in IT for 20-something years, a little bit too long. Currently, I'm a student with KU Leuven. And I am kind of finalizing the PhD in hopefully 2 months. But this this journey kind of started about 20 years ago when I was seeing that projects are getting more and more complex and more challenging. And when I started to do also project management and then department management, we were seeing larger projects, more problems and so on, but more and more rewarded. And everybody knows the statistics from the Standish Group in '95. They were updated 2 times. The numbers are staggering. I mean, 31% of IT projects canceled, 52% cost double the estimate. Only 16% are matching the original estimates. And it was troubling, but also interesting that we are still, the numbers are much better now. But in principle, they are okay, and they should not surprise us, because we are dealing in IT mostly with R&D, research and innovation. And we know from marketing that in product design and development, in pretty much any field, only 1 of 10 product research ideas are getting to market. And out of this, only 1 in 10 is a success. So now, the question was coming, why are we doing this? I was seeing that all IT projects are complex, have some traits of complexity, and some are really significantly complex. I mean, when you are going to huge projects, like one of the case studies that I've been researching is, for instance, the Schengen Information System, the SIS2. It was estimated to take a few years, and it took about 10. And we are talking about hundreds of millions of euro. And there are other examples that I think I gave in the paper as well. Implementation projects, the SAP implementation, for instance, done at Shell, if I remember correctly, by IBM. The numbers are probably not public, but it was a huge delay and a huge overcost. So this was the start where I started from, trying to research and understand project complexity and see how we can manage. And this is one of the things that was interesting in the journey, is to understand what is complexity and what is project complexity. Because when we are saying complex, we typically mean difficult. Also a little bit fashionable. We say complex, but what does complex mean? Well, say complex about nice things and difficult things. The definition that comes a little bit from mathematics but I adopted and used throughout this research in IT project complexity management, is that a complex project is difficult to understand, foresee, and keep under control, even if you know a lot or everything about its components, about the project. There are 2 aspects. This is a little bit of an introduction to the topic to make sure that we are on the same page. There are 2 aspects. One is structural complexity, which is mostly complicated. It means a system, a project is composed of many varied interrelated parts. But there are also dynamic complexity aspects, such as chaos, ambiguity, uncertainty, unknown unknowns, and so on. We are talking about strange effects like black swan, the one invented by Taleb, or the butterfly effect of Lorentz. You know the paper, he didn't invent the term. The term comes from Ray Bradbury, from a novel he wrote 20 years before Lorentz mathematics paper. And this means that we can clarify projects, classify projects as simple, or systems, because this is a systems classification, as simple, which require no effort. Then we get to complicated, where you need effort in order of the effort to manage it. And there is this category of really complex projects. The idea being that in a complex project, it is very difficult or impossible to understand or to forecast what is going to happen. But in a really complex project, it's almost impossible to understand why things already happened, because the relation between causes and effects in the past is already unclear. So this was an interesting epiphany that I had. It was 2018. I was on the seaside. I took a half a year sabbatical after about 18 years of work, continuous work in IT project management in the private sector, mostly working with European projects for the European Commission, for instance, and so on. So I tried to take a 6 months, 1 year sabbatical. When I was on the seaside, I did some biking and some sailing and played some guitar, and I read some books. And one of the interesting books, which really was for me really important, was a book of Maurer, a German scientist, who said something that made we have it all around us. It is ubiquitous. We see we are in an age where we have complex projects because with complex organizations and with complex processes, and these projects deliver. What I mean that it works is we see around us smart cars, rockets, smartphones, vaccines, and Viagra and robots. And they are complex products, but we still deliver them with complex projects. So, you know, Viagra, by the way, as well as the SMS, there are two really interesting examples of how complexity works in IT project management, because well, Viagra is not really IT, but SMS is, and the mechanism is the same. These are two products that are currently really successful, and they are used completely different from what they were originally intended. They resulted from an error, basically, a mistake, which is not from research projects, from huge investments. And they are really beneficial. But it was not a linear process. Nobody said, I want to design a product called the SMS or called Viagra, which will help in this area. No, there was a different research project. There was a different product. They investigated it for years before they came up with the result. And they discovered that the result was very useful, but really different from what was intended. And this is an impact of complexity. And another example is Facebook. I think it's a great example of what IT complexity and IT project complexity means in today's world. Because what is Facebook? It is a collection of software code, people, together with the founder and owner, of content, a lot of multimedia and text, of people, the users, the developers, the marketing guys, and so on and so on. And can we say that Facebook is the sum of all these components? Absolutely not. Facebook is not code. Facebook is not content. It's something else. And this is interesting because I discovered that the first one to say this was Aristotle, when he said the whole is different from the sum of the parts. Aristotle, 2,500 years ago, discovered the definition of a complex system. And he was followed, I think, a few hundred years ago, or after 100 years or something, after by Euclid, who said something much more simple, which actually defines a complicated system today. Euclid said that the whole is more than the sum of the parts. This is exactly the definition of a complicated system or a complicated project. But what we are talking about here with Facebook is more than that. The result is a social phenomenon. It is completely different from the code. If you take it's nothing from the code will tell you what Facebook is. It's different, which tells us that the complexity can be positive. It helps with innovation. Innovation occurs at the edge of chaos, somewhere else. This concept is similar to the opportunities, which appeared about 30 years ago in project management and now becomes a little bit mainstream. We do risk management, and within risk management, we do opportunity management. which is the positive side of risk. It's not so old, the concept. I really studied the history of risk management for the last 120 years, and I only discovered it about 20 years ago. The concept of opportunity appeared about 20 years ago, in 90 something. Before that, it was all negative. And interestingly, there is a very recent book by Taleb. It is called Anti-Fragility. And he actually says exactly this, that it is talking about vulnerability management. And when we have a vulnerable system, we are typically talking about resistance and resilience, right? But this is all negative. And Taleb comes and says, no, there are also systems who are getting better because of adverse circumstances. And he calls this anti-fragility. And I think the concept of positive complexity that we pretty much invented is the same thing in IT project management. So we define positive complexity as when the benefits are higher than the cost of that complexity. For a rigorous model, there is appropriate complexity, which is similar a little bit with requisite complexity. It means that you have complexity, you leave it there because it is too expensive to take it out. And negative complexity, which is the typical traditional way to look at it, which is typically solved by divide et impera, by simplification and decomposition are the key tools and this is what you will find in any paper or research regarding complexity management. Simplify, reduce. But what we are trying to say is that it's not enough, because sometimes you need to use that complexity and sometimes you actually need to create complexity. So where do we get from here? Well, similar to what we do with other topics, with all the topics that we have in management and in engineering in any level, we create a framework, a model, a management framework. So this is what I'm going to present next. After studying some examples of management frameworks that are being applied in lots of areas, especially in PMBOK, but not only. I mean, I think I looked at over 20 management frameworks. We came up with a simple 5-step procedure that is presented here for as a management framework for IT project complexity management, which is plan, identify, analyze, plan responses, and monitor and control. It is quite similar to risk management, of course. And as a more detailed view, in the initial planning phase, you need to identify if a project is complex and to decide how you want to manage it. What do you want to do about it, if anything? In the identification and analysis phases, you are looking at what are the components of complexity in the IT project. It's understanding, and visualization is a key method. I put it here specifically different because it's more than identifying and analyzing. It helps. It can be considered a step in itself. The next step is what are you going to do about each element of complexity that you have in front. So here we used the model that we mentioned, the complexity effect scale of positive, appropriate, and negative, which I would like to repeat, these are effects of complexity. So we define this tool, which we called the complexity effect scale. And based on what I discussed earlier, you can classify the effects as positive, appropriate, and negative. And of course, this is what drives the mitigation strategies that you can use. You can simplify, reduce, decompose the complexity that is negative, which is the traditional school. You can accept in all cases, but this is mostly appropriate in the case of appropriate complexity. I mean, it is there, it is too expensive to take it out. You leave it there, and it's important to know about that decision. And of course, we introduce new methods of create, enhance, use, exploit positive complexity. And the examples that I gave now I think we can apply them. I mean, let's imagine we design a new smartphone, and we discover that we need to add complexity because users have found new ways to use a smartphone. We are creating complexity in our product and in the process to produce that product, and then in the organization that is designing and manufacturing that product, and in the project around this. And this is what we propose to acknowledge, that we are purposely creating complexity in the products, in the IT products that we deliver in design. And it's not a mistake. Sometimes it is a specific purpose of our project. Another example, we typically do, both in research as well as in IT design and development, we mix teams of different backgrounds, different cultures, different ideas, because this mix creates innovation. And this is how you get a new competitive product on the market. So we created complexity, we created a team, which is really difficult to manage, difficult to discuss, and so on, because we expect things to come out of it. And then, of course, the last phase is manage. The framework, this is an integrated view of the framework, which consists of, I think the image is difficult to see, so I prepared a Zoom version, if I can find it. It was a Word document here. I think this is better. So how do you describe such a process? Well, a typical approach would be to look at, for each of the processes in the framework, to look at the inputs, outputs, and tools and techniques. For instance, for planning, inputs are the typical project management and IT inputs. You have the scope statement, the cost plan, the schedule plan. The outputs is decide if the project is complex or not. This is red flagging and the complexity management plan. And the tools, for instance, complexity measurement. Tools that tell you if a project is or not complex. For identification of IT project complexity, you look at scope statement, stakeholders, you look at the risk register, of course, and so on, and you come out with what we call the complexity register, which is combining several other tools. And the list of tools, the complexity effects scale tool is a source of identifying and looking at complexity. Looking at breakdown structures, of course, the product breakdown structure, risk breakdown structure, the classical work breakdown structure, and so on. For the third phase, you have all the details in the paper. I'll just go very quickly over them, and please come back with questions, if any. So for analysis, of course, you can do quantitative and qualitative analysis. Sometimes, for some aspects, of course, like in risk management and in any other domain, you can do quantitative analysis, quantifying the effects in financial terms, for instance, but not for everything. Some aspects are really not quantifiable. You only perform qualitative analysis. The tools to analyze, for instance, tools that we identified as part of the inventory that was done during the research for this paper, were things like visualization tools, diagrams. Dependency diagrams are critical for structural complexity management, or multidimensional dependency diagrams. Also from systems thinking, sorry, it's causal loops, and pretty much the tools for modeling and design that we typically use in IT are usable in complexity management, because you analyze, describe the product that you have. So we're talking about UML or SOA modeling language or system modeling language and so on. For planning strategies, the main tool that we propose is the Mitigation Strategies Matrix, is the tool that I presented earlier, and I will get back to it immediately. The one where you decide what kind of strategy you can take for any aspect of complexity. And now for monitoring, controlling, it's pretty much, monitoring tools. And the list here is formed mostly of the tools that are already available in the inventory of the project manager, of the IT project manager or engineering manager. I mean, there are only 3 words here that are new, only 3 tools that are new, and that I think I will go very quickly next through them. If I find my button. So first question, how do you identify, measure complexity? How can you say that the project is complex? There are 3 tools here that I gave as example. This is Vidal's refined project complexity framework. It is formed of a number of items. If you answer with yes to a significant number of items, this is a form to classify complexity, project complexity. Another tool that we identified as part of the inventory is the Crawford-Ishikura factor table. It is another tool that can be used. It has 7 items. You rank based on 7 criteria your project, and in the end you get a score. Another tool, interesting tool that we discovered that already exists, I think it's already 12 years old. It's HAS, the project complexity model formula. Here is the results applied in a different project of the HAS complexity scale. So you take every of these items, we actually, give a score for each of the criteria, and in the end you get ranking between projects. The first tool that I proposed, specialized tool for complexity management, was the complexity effect scale tool. This is the second one, is organizing complexity elements by effect, positive and appropriate, or negative, and by source. An example of classification by source is internal and external, but there are also other possible classifications. So this is pretty much a segmentation tool. The mitigation strategies matrix tool is the one that I already introduced. This is the tool that will support the IT project manager taking decisions regarding each aspect of the project and saying this one, and deciding on what to do each one, how to mitigate each of them. For managing, an interesting conclusion that we have is that oversimplification doesn't work. It's counterproductive in a lot of areas. We discovered, of course, that managing a complex project as a program is a key tool in managing complex projects. And in the end, some empirical observation that I did lots of years ago is that I never seen an IT project going on track and saying, you plan it and you execute it. It's always a little bit of a mess there. But saying that you have a good project, it's not about having a clean project. It's having a project that delivers its results. So the question is, okay, we have difficult projects and complex projects. And the key question is how to make it work. Just 2 examples of what this is a dependency matrix. This is a typical tool that you can use for structural complexity analysis. This was proposed by Maurer, I think, and this is another one proposed by Vidal. It is the multiple domain matrix, also dependency modeling. These are tools that can be used to model, analyze complexity in the components of the project. The typical way to manage dynamic complexity management, dynamic complexity is monitoring for change. We are here talking about black swan effects, as Taleb called them, things that you don't know, and that will have a significant impact on the project. and then what do you do? I mean, you don't know that you don't know that that something is going to happen, or that a phenomenon is going to characterize your project. The most important tool is monitoring for change. Simply monitoring is you are already doing a lot. And this is pretty much my last slide, kind of a formal conclusion to my discussion, which I feel was kind of condensed. This is that the framework that we propose, the main objective, we aim to support recognizing when complexity occurs, to understand it, to analyze it, and to manage it. The steps that we proposed. This is an interesting observation to make. Do we expect every IT project manager to implement such a framework for all the projects? Clearly, no. First of all, you only need to do that for really complex and large projects. If you have a small project, a 2-day development or a 2-week development project, simply implementing a new tool is more expensive than anything you are doing in the project. Doesn't make sense. So you need these tools are coming with an overhead, so the project needs to allow the cost overhead. The second point is that no, even for large and complex projects, you do not implement exactly such a framework, because in practice we don't. In practice, I'm coming from the industry. I've been doing 25 years of IT projects. I've never implemented a process a la carte, exactly by the book. I mean, I know risk management. I've been doing risk management for most of the projects that I've been doing. But am I going to apply the 5, I think now there are 6 steps in PMBOK. They introduced this one more step last year. So am I going to implement step 1, 2, 3, 4? No, really no. The idea is that I know the principles, I know the tools, and I'm choosing which tools to actually deploy in my project. And this is what we expect from complexity management as well, to be an available tool and to create awareness to the project manager and to the engineering manager and team about it, so as to be able to choose when and what to do about it. Thank you.
Okay, thank you, Stefan. There are quite a few of us on this call, so there's 14 people. So we've got a couple of minutes, I think, and I recognize that we're tight on time today, so I think we should stick to time. So I'll just open it very quickly for a question. Anybody with a question? Anybody want to ask a question? Okay, can I, if nobody...
We have a raised hand.
All right. Sorry, I didn't see that. Who is that? Sorry.
It's okay.
That would be me.
Great, go ahead. Go ahead and unmute. You can unmute.
Thank you for your presentation, Stefan. Really interesting. What I see in practice is a shift to more agile work forms. So with less project managers and more product owners or that type of personnel. How do you relate your model to that shift to more agile work forms?
So Agile is one of the main tools that is already in the inventory that we analyzed and proposed. Agility is the way to deal with, one of the forms to deal with complexity. And it's probably the key one. It's an observation that was made lots of years ago. I'm discussing this a lot with my younger colleagues that are huge adepts of Scrum and Agile. Scrum and Agile are not new. They are solutions that were invented 20, 30, 40 years ago. And they are not the only ones. I studied in a master's 20 years ago about spiral development and iterative incremental development, which are also form of Agile. In my work, in my industry practice, we are using Scrum Agile a lot. And again, the answer is that Agile is one of the critical tools, the most important tools on how to manage IT project complexity. A little bit more than that, everything that we implement as managers and as engineers, I'm an engineer, is a little bit agile, is iterative and incremental. I mean, how do we design tools? Because we are doing research. How do we design tools? We do iterations and increments. We start with a model, we design a model, and then we test it, validate and evaluate it, which, by the way, is we have also 2 projects for validation and evaluation of this particular research, which are separate projects. One is already published and the other one is being in work. So what do? We design a product, we then test and validate it, and maybe sometimes also evaluate, and then we redesign the product. And this is pretty much what Agile is. And this is also, as you are seeing here, included in the model itself, the iteration. I mean, you plan it. Okay, that's a formal step, not really clear if it's a process at the beginning of the project. But then you have, for complexity management, you have to identify, analyze, plan responses, monitor and control, and get back. And this is what we do for most of the processes in project management, as well as in IT development. I also believe that waterfall, linear development models are not really suitable for modern IT projects.